beneath the endless blue of the Pacific Ocean, hidden from human eyes and resting near the deepest part of our planet, something extraordinary awakened. On November 21, 2024, the colossal underwater volcano known as a high seamount, located near the infamous Mariana Trench, erupted with incredible force. It was a spectacular display of nature's raw, untamed power, discoloring the ocean waters and releasing mysterious floating pumice that drifted across the waves like ghostly messengers from the deep. This was not just a geological event. It was a planetary signal, a reminder that Earth's inner forces are still alive, still shaping our world from beneath the waves. Within hours, the Northern Mariana Islands Volcano Observatory raised the alert level to advisory, and the aviation color code was set to yellow, both clear warnings that something significant was unfolding. Maritime routes and airspace over the region were put on high alert, as scientists around the globe turned their attention to this enigmatic giant, now fully awakened. But what exactly is a high seamount? Nestled in one of Earth's most tectonically active regions, this massive submarine volcano lies approximately 18 kilometers southeast of Farallon de Pajaros. Its summit is just 75 meters beneath the ocean surface, a slumbering leviathan hiding just below the waves. It forms part of the Mariana Volcanic Arc, a fierce chain of geological activity fueled by one of the most dynamic forces on Earth, subduction. Here, the Pacific Plate dives beneath the Philippine Sea Plate, dragging with its centuries of oceanic crust into the Earth's mantle. This immense pressure and heat generate magma, molten rock that seeks release, and when it finds its way to the surface, it births a volcano like a high seamount. This particular eruption wasn't sudden. It began months earlier, in August 2024, and satellite images soon revealed signs of consistent eruptive behavior. In this remote part of the ocean, where seismic monitoring is sparse, scientists turn to advanced technologies, satellite imagery, remote hydrophones, and ocean sensors, to monitor the unfolding drama. Yet, oddly, hydroacoustic sensors picked up no strong signals. The eruption, it seemed, was loud in spectacle but quiet in sound, another mystery of the deep. Unlike land-based volcanoes with extensive seismic networks and constant observation, submarine volcanoes like a high seamount are difficult to monitor. That challenge is what makes every image, every data point, every floating pumice stone critically important. Researchers studied water coloration changes, temperature anomalies, and clusters of gas bubbles rising to the surface. Each sign told part of a story, hinting at the incredible geological activity happening far below. What they discovered was astounding. A volcano not only erupting but reshaping the ocean floor. This isn't the first time a high seamount has roared to life. It's a geological veteran, with a history of eruptions stretching back decades. In 1979, fishermen reported violent shocks and sulfur-stained waters near the summit. Then, in 2001, seismic stations as far as Rhode Island, hundreds of kilometers away, detected an explosive eruption. In 2014, another significant event was recorded. This eruption was so powerful that it created a new summit crater and triggered a massive landslide on the southeast flank, physically transforming the seamount's structure. More recently, it erupted again between October 2022 and May 2023, and once more from December 2023 to April 2024. These back-to-back phases confirmed what scientists already suspected. This was no dormant mountain. It was one of Earth's most active undersea volcanoes. Yet, its remoteness makes it a silent threat. The floating pumice released can damage vessels and disrupt maritime operations. Ships crossing the area must now navigate with caution, aware that beneath them lies a cauldron of molten earth. The story of a high seamount begins not with fire, but with the slow, grinding movement of tectonic plates. The Mariana Arc, where it lies, is shaped by the Pacific Plate plunging beneath the Philippine Sea Plate. This subduction zone, home to the Mariana Trench, is the engine behind the Arc's explosive volcanic activity. As the Pacific Plate sinks, it carries with it trapped water and minerals. These volatiles escape into the upper mantle, lowering its melting point and creating buoyant magma. That magma forces its way upward, erupting through Earth's crust and forming undersea volcanoes like a high seamount. Over millions of years, countless eruptions have built its structure, layering rock upon rock. Today, its summit lies only 137 meters below sea level. Though not yet an island, continued eruptions may one day thrust it above the waves. The seamount structure is uneven, shaped by relentless forces: volcanic pressure, shifting tectonics, sudden landslides. This cratered summit tells the story of past explosions. Its flanks bear the scars of instability, where lava flows and underwater earthquakes have carved steep, unstable slopes. The nearby Back Arc Basin, where oceanic crust forms from seafloor spreading, contributes even more magma to this growing mountain of fire. Despite all this activity, scientists believe it is unlikely that a high seamount could trigger other volcanoes across the Pacific Ring of Fire. This vast ring, stretching from the Andes to Alaska, Japan to New Zealand, is driven by multiple independent subduction zones. Each volcano, including a high seamount, is controlled by local geological forces. The magma that fuels eruptions in the Mariana Arc is not connected to the systems that drive volcanic activity in the Andes or Cascadia. However, indirect effects are possible. Powerful eruptions or large earthquakes can shift regional stress fields, potentially influencing nearby volcanoes if they are already primed to erupt. And through a phenomenon known as dynamic triggering, seismic waves from a major eruption could ripple across the crust and disturb distant systems, but only if those volcanoes are already on the brink. For now, the influence of a high seamount remains largely local, immense, but contained. To understand its potential, scientists compare it with other massive underwater volcanoes. Take Hunga Tonga, Hunga Hapai, for instance. Its 2022 eruption was one of the most powerful ever recorded, blasting ash and water vapor into the stratosphere and creating tsunami waves across the Pacific. The atmospheric effects were global. By contrast, a high seamount's eruptions, while intense, remain beneath the sea. The greater depth of its summit means that water pressure suppresses explosive activity, reducing the chances of an atmospheric eruption. Instead, it releases discolored plumes, gas bubbles, and floating debris, a more subtle, yet equally important geological process. Still, the seamount is far from quiet. Its persistent activity continues to reshape the seafloor. As magma pulses upward and crustal plates grind against each other, this submarine volcano grows, shifts, and evolves. Studying its behavior helps scientists understand not just one volcano, but the entire dynamic nature of Earth's geology. The data gathered from these ongoing eruptions are critical. They provide insight into the processes that shape ocean basins, the risks posed to shipping, and the long-term evolution of submarine volcanoes. Floating pumice can travel vast distances, affecting marine ecosystems, disrupting shipping routes, and even altering oceanic chemistry. Monitoring this undersea giant is no small task. But through satellite imagery, hydroacoustic sensors, and cutting-edge marine technologies, scientists are pushing the boundaries of what we can know about these hidden forces beneath the waves. As the seamount continues to rumble and shift, the question remains: is this the start of a new, prolonged volcanic phase, or will it settle back into silence once again? Whatever the answer, a high seamount stands as a powerful reminder that the Earth beneath us, and beneath the oceans, is alive. Always changing, always moving, and always capable of stunning, transformative displays of nature's power. Narrator quietly with weight. From the deepest trenches to the highest peaks, Earth never stops breathing. And in that breath, we find the story of our planet, written in magma, stone, and time.